Alright, this is a quick video of how to build a stove fan. I've never built one myself, but I've seen the videos on YouTube where people have had a go, but they don't really show you the steps involved in actually building it. They just show you the finished product, and then you're left to sort of decide how you have to do it yourself. So I'm just going to give you a quick overview of the parts used and what I've used. I'm by no means an expert, so you can improvise and change stuff to suit yourself, obviously with what you have. So I'll go round what we've used. I used a Zalman CPU cooler. I've done a bit already to it, so ignore that. But this was, I think it was about £15 off Amazon with free delivery. So I mean, it's alright price, but if you could get one second hand with all the attachments and screws and stuff, obviously go for that, because you're only using it as a stove fan. So that's what you get. You get the cooler with the fins, comes with a fan, all your different parts, brackets and stuff for the different styles of whether it's an Intel or whether it's an AMD. Your user manual. For the base, I used what used to be a little amp. For the base, it's made of aluminium. I've buffed all the paint off, or all the paint I could get at. I will be painting this black with stove paint, but it used to be a blue version of one of these, which was just a wee amp, had a circuit board. You can see the standoffs in there. And I've basically stripped it down, and I'm going to use it as the base. What else I've used is the Peltiers, which everyone uses for these. I've marked them C for the cold side. These, I think for two, it was about £7 off eBay. And basically, if you don't know what these are, they're thermocouples. So you have your live and your neutral there. If you were to put power to this, one side will go cold and the other side will go hot. But for this application, what will actually happen is the reverse. We'll put it in there and the stove will heat one side, the cooler will cool the other side, and then it'll send a voltage, not a very high voltage obviously, down to the leads, which in turn turns the fan. So I've two of them. Now these aren't high temperature ones, but I'm trying to use them because the high temperature ones that are rated to about 300 degrees are about 30 odd pounds from America, whereas these ones for two was £7 off eBay. So if I can get these to work and it does the job, well, it's all the better. What else? I've got a little copper plate that I got off another CPU. It was actually something similar to this. And I just hit it with a blowtorch and it melted the solder and the plate dropped off. That's for helping to sandwich these. And an aluminium plate because the copper one wasn't big enough, so I'm using a copper, then an aluminium, just to span those two for when they're getting sandwiched onto the cooler. I also got a solar motor. I think it works from round about 1 volt up to about 9 or 12, can't remember now. But this is what everybody uses for the stove fans, and again it was cheap off eBay. Can't remember the price now, about £3–4 or something off eBay for a solar fan. And what else was the fan blade itself? I got this from, I think it was like the canal shop or something like that there, for people that have canal boats, narrow boats. And they use a lot of these stove fans, and instead of making my own blade, I thought for the sake of, what was the price? For the sake of £11.95, I might as well get one that is designed exactly for the job. £11.95, it's not a big outlay for a fan blade, when you consider maybe a sheet of aluminium would cost you £5 and the amount of time that you would take getting something exactly that shape. It's just worth, I think, paying just an extra few quid to buy something purpose made. So I got that, and it comes with a little Allen key. That's going to fit onto the solar motor, which it's a pretty good fit. And then all you do is wind in the grub screw to tighten it onto the motor. So that's that, and I pretty much think that's all the parts. There's other bits here that I've improvised with. This bit that you see on top of the cooler is basically just a piece of metal that I found. I'm not sure what these are off, whether it's off furniture or I don't know, old amplifier or something. But what I've done is cut this and used it and pop riveted it onto the top of the cooler, and then put a hole in it for the outside of the shaft of the fan. And what these solar fans actually have as well is 2 holes either side that are threaded, and I have 2 small screws made to go into this. I think these were originally from their Torx screws. I think these may have been from an Xbox controller, and I just basically cut them down because you don't want the screws obviously going too far into the fan. So the fan, I've pop riveted it on, I've sprayed the bracket black, and I've sprayed the top of the cooler black as well, just to make it look a bit better. And the little piece that protrudes out of the fan that holds the spindle fits into that hole, and then I have these 2 holes lining up with the holes that are already drilled and tapped in the fan, and then it's just a matter of putting these screws in, and that will hold the solar motor in place onto the top of the cooler. So that is all the parts, more or less. I'll just actually show you what way I plan on doing it. Now I'm making this up as I go along, so obviously it's just a guide, maybe give you ideas yourself of how to do it. So basically what I'm going to do is I'm going to have the base, this is going to be sprayed black apart from the part that's going to be in contact with the 2 Peltiers. So the 2 Peltiers are going to sit on the base, and then a bit of thermal paste underneath, and then a bit of thermal paste on top. Then this small aluminium plate. Obviously, if you have one bigger, thicker plate of aluminium or copper that can span those 2, it's better than obviously having 2 thin ones. But I'm just using what I had or what I could find in the garage in the shed, so that's hopefully going to go there. And then I have the brackets for the, I think it's the Intel CPU. There's other ones in there that are straight rather than have the dog legs on them, and they are for the AMD. So depending on what you use for the base, those ones could be more handy for you. And you can see actually that comes with the thermal paste as well, and all the screws and the brackets for holding on the fan. We won't need the fan, so you can keep that for something else. So this is going to sit on top of that, again thermal paste. And I'm hopefully going to be able to use some of the screws that came with the cooler to go through the base and clamp down with a bit of pressure, not too much, just to hold that all in place. And obviously then you have the solar motor and then the fan. And then I haven't decided yet what I'm going to do with the cables. I'll maybe run them up the back and then through the fins, and then solder them onto the motor. But what I should say is the likes of the motor and the Peltiers, they don't last forever. From what I've heard, I haven't used them myself, but even on the commercially bought ones, you have to expect that they're going to fail, or you can expect that they're going to fail. Everything else should be fine, but the motor and the Peltiers are the sort of fragile parts of the build. And the thing about these as well is, because they're not high temperature, I've used this sort of thin aluminium box, whereas if maybe you're using a high temperature one, you'd use just a small solid block of aluminium straight onto the stove, and then the Peltiers. but because these aren't high temperature, I've lifted them off and used something quite thin gauge, so it's hopefully not too much heat transfers into the Peltiers. And then what you can get is the solder apparently can creep, even if it doesn't get to the sort of listed melting point of the solder. It can creep if it gets close to it, and then the Peltiers fail. So I'll put a few more parts on it, and then I'll talk you through what I've done, and hopefully it might help you if you want to build one yourself. So I'll pause it here, and then when you come back I'll show you what else I've done. Alright, so I have sprayed the little box that I'm using, except for the parts that are in contact with the stove and the part that's going to be in contact with the two Peltiers. And what I've done with them as well is I've linked them in series. So I have soldered the red here, the positive, with the negative here, and joined them. You can't see them, they're under the foil. And then this is the two that will run to the motor then, the positive and the negative. So that's them in series. You probably could get away with using one in one of these, but because I'm not using the high temperature variant of these, I'm reducing their effectiveness, but at the same time I'm trying to preserve them. So that's why I've got two, so hopefully I'll get double or close to double the power than you would with just the one. So those are going on, and then I have my plates again. Instead of having two plates that I've just scavenged, if you had a little milled block of aluminium that spanned two, you could use that, and it would be far more effective than putting thermal paste between these and letting them span the two Peltiers. So that is going on there. Thermal paste again. And then I'm going to put on the cooler. Again, thermal paste on the bottom of the heat pipes here. Just a thin smear of thermal paste, and it's going to sit on that. And what I will do then is I'll use the bolts, or 4 of the bolts that came with the cooler, and I'm going to bolt this down under moderate sort of tension just to keep that in place. And I will do that, and I'll maybe put more foil around these once I know what sort of length I need from the reach of the motor, and then I will come back again and show you what I've done. Okay. Alright, so as you can see, I've put most of it back together again, and I've put the motor in place, brought the cables through the cooling fins near the top just so you don't see them, and then if you can see in behind the motor there, I've left a bit of slack on the wires just in case I ever need to take the motor off again. And you can see there the colour of the spindle through the hole, and the two short screws straight into the threaded holes in the motor just to hold it in place. I have everything sandwiched in there with thermal paste, and I was able to use the screws that hold the heatsink in place on the motherboard. I had to use a couple of washers on each one because they were a fraction too long, and I also used mylar washers underneath in an effort to try and stop some of it. You won't stop it all, but stop some of the heat travelling straight up through the screws and into the heatsink. So it would obviously be bypassing the Peltiers. Not vitally important when you're only powering a fan, but if it was a project for producing electric or something, obviously you'd want every bit of heat going through the Peltiers rather than through the screws. And that's more or less about it. I have had this put together and running on the hob in the kitchen, but what I've noticed is it's hard to get an accurate reading. I have a laser thermometer, but it's hard to get an accurate reading on a ceramic hob because it tends to pulse on and then off again, so you can't get a steady reading. But I did notice, and again I don't know what temperature the number settings are on the hob, but the setting that I had it at was about 7, and I did notice that the base of this, the top of it, got up to 190 odd degrees, which is too hot. So I don't know whether in normal running mode on the wood burning stove, whether I would get that much heat going through to the top of this in its current layout. So what I've done as well, just to try and lessen that, is I've put 4 feet on it. There was already holes in it for securing this wee box onto the wall, so I've put 4 feet on this to try and reduce the amount of heat conducted through the base. But I think quite a lot of the heat is just radiated straight to the base of this. So what I might do as well, I might use these standoffs that used to hold a circuit board and put some sort of reflective panel in there to reflect some of the heat back down, because at the end of the day we don't need this thing at full tilt. We just need it you know, a happy medium between the amount of heat that this can take and fan speed. So I'm just trying to find that balance where I can preserve the life of the thing and it's still being useful enough to pump enough heat across the room. So I have that to do, and the fan blade is the last part. Now the fan blade has a wee grub screw here and the hole for the spindle, and what they recommend, the fan manufacturers recommend, is that you push it until the spindle is flush with the what would you call it, the hub of the fan. But you can't do that because of these wee screws, or I can't do that. If I had used maybe smaller, flatter ones, it wouldn't have been a problem. So what I have to do is push it on and then make sure I have enough clearance. Shouldn't be a problem though. And then tighten it up with the Allen key. And that's it. It's very close to the screws, but it's not close enough to hit them. And that's about it. So as you can see, it's not that difficult to put together, but I don't think it's fully ready to go yet, because what I think I'll do is take a few readings of the stove. It's a warm day today, so lighting the stove is going to be an absolute joy. But I'll light the stove and get it sort of running at its steady temperature, and then I'll put the fan on, and then I'll take readings around the stove top, run readings around the fan, and then that'll give me and you an idea of you know, whether this design is good enough for just the ordinary running of a stove, or whether it maybe needs to get elevated a bit more to keep it away from the heat that's radiated rather than conducted. But we'll have a go. I'll light the stove and we'll see what happens. Alright, as you can see, the fan's going well. It's a wee cheap stove. Has been going now for about an hour. It seems to have settled down, and it's sitting, according to the stove thermometer, at about 250. Which isn't a mile away. The centre of the stove probably sitting, yeah, over 300, 350 say. Back of the stove 270 odds. Front of the stove below 200, 180. So the fan speed is just where you'd want it to be. It's not putting out the same amount of or displacing the same amount of air as a desk fan or anything like that, but it's enough for a stove fan. And let's just see if we can if you can see that. About 130 below the Peltiers. About 100 or so above. So about a 30-degree difference, and that's enough to get that amount of speed on the fan, which I'm happy enough with. Now I fitted the feet onto the fan because too much heat was getting or conducting up through the base as it was, so it was going too fast and risk damaging it. And if I can lift this without burning myself, you can see there I fitted a reflector as well, just to cut down the amount of heat radiated up through the base. So it's a bit of a balancing act, but I think that's just about right. So that will hopefully circulate the heat through the living room a bit better, and that's about it. So if you have any questions, I'll certainly have a go at answering them. As I say, I'm not an expert. I've just put this together through videos and articles off the internet, and a lot of trial and error. So as I say, any suggestions for how it could be improved, or if you want to help other people that are making comments, go right ahead. But that was my go at it anyway. Okay, good luck.